Over the following 8 years, Mendel planted an estimated 28,000 carefully controlled crosses between different varieties of pea plants. He explored every possible combination, sometimes for up to 7 generations, and meticulously counted the results. One of the contrasting features that Mendel studied was the color of the plant's flower. One of his true breeding varieties always grew purple flowers, another always grew white ones. Their seeds formed the parent or pea generation. As soon as buds appeared on the vines, Mendel carefully opened them and removed the stamens to prevent self-fertilization. He later took pollen from purple flowers and sprinkled it on the pistils in white flowers. He also did the reverse. To prevent contamination by wild pollen, he then wrapped the flowers with protective bags. As a further control, he moved some of the plants into the insulated environment of a greenhouse. Weeks later, both groups of cross-fertilized plants developed seeds. Mendel stored the hybrid seeds over the winter and planted them the next spring. When the plants in this first hybrid or F1 generation grew flowers, they were all purple. Mendel called this trait the dominant one. He termed the trait that disappeared in the F1 generation recessive. Mendel let these F1 hybrid plants self-fertilize and produce new seeds. The next year, Mendel planted the F1 seeds, producing the next or F2 generation of plants. This time, there were some white flowers mixed in among the purples. He was well aware that traits sometimes skipped generations, so this was no surprise. But Mendel discovered something that no one else had ever noticed before. He counted the number of white and purple flowers. In similar fashion, he counted the results of crossing 6 other contrasting traits through to the F2 generation. When he worked out the ratio of dominant to recessive, in each case it came very close to 3 to 1.